Today we're going to talk about graphs of equations. We'll start with the definition. An equation with two variables is the relationship between the two variables. A variable is something that changes, where something that remains the same would be considered a constant. For example, a equals pi r squared. That is an equation that relates two variables. You should recognize this as the area of a circle. Well, depending on how big your circle is, the area and the radius would change, so the a and the r are your variables, but the pi will remain the same. That's a constant roughly equal to 3.14159. Another example would be y equals mx plus b. You should recognize this as the equation of a line. X and y will vary depending on where you are on the line, but no matter where you are on the line, the slope will remain the same and so will the y-intercept, so your m and your b are your constants. Here's another definition. A point is considered a solution to an equation if the statement holds true when you plug the values in. So for example, let's determine if the ordered pair 4, negative 1 and negative 1, 3 are solutions to the equation y equals negative x plus 3. Remember, your ordered pairs are written x, y, so to check 4, negative 1, we'll plug in 4 for x and negative 1 for y. And when we do that, we'll distribute that negative to the 4. Negative 4 plus 3 does give us negative 1. So we do get a true statement, so we can say that 4, negative 1 is a solution to that equation. Now let's check the other point. To check negative 1, 3, we'll plug in negative 1 for x and 3 for y. So we'll have to distribute that negative. Remember, a double negative makes a positive, and 1 plus 3 is 4. Well, as I'm sure you know, 3 is not equal to 4, so that does not give us a true statement. So that means negative 1, 3 is not a solution to that equation. Now our next definition is the graph of an equation. This is the set of all possible solutions. Well, many equations we deal with actually have infinitely many solutions, and you can't actually plot them all or find them all. So what we do to graph an equation, we'll go to our old school method of graphing. We'll pick some x values, plug them in to get their corresponding y values, graph a few ordered pairs. Once we see the shape of the graph, then we can draw the graph to represent all the equations. So I just picked a few random x values, negative 2, negative 1, 0, 1, and 2, and I plugged them into the original equation y equals x squared minus 3. And then I got my corresponding y values. So I have the ordered pair negative 2, 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, 1. So when I plot those points, you can see the parabola forming, so then I can graph the parabola. Now this parabola represents every single ordered pair, every single solution to this equation. Even though they're not highlighted in a dot, you have a solution right here, and here, and here, and here. There are infinitely many solutions to this equation. Another definition we have, the point where the graph crosses the x-axis is called the x-intercept. So think about where the x-axis is. When you cross there, that's where y equals 0. The point where the graph crosses the y-axis is called the y-intercept. And think about the x value there, the x value 0. So you can actually use this definition to help you figure out how you would find the x and y intercepts. So let's find the x and y intercepts of y equals x squared minus 2x minus 3. Finding the x and the y intercepts are independent of one another. You don't need the x-intercept to find the y, so it doesn't matter which one you do first. So we'll find the y-intercept first. So remember, at the y-intercept, x is equal to 0, so that's what we'll do. We'll plug in x equals 0. And when we do that, we get y equals negative 3. Now, intercepts are points, and points are written as ordered pairs, so the y-intercept is the ordered pair 0, negative 3. Now we'll find the x-intercepts. To do that, we'll plug in y equals 0. So we get 0 equals x squared minus 2x minus 3. Now this is a little different than the last example because in order to solve this, we are going to have to factor. So this will factor into x minus 3 times x plus 1. And now we'll set each of the factors equal to 0. X minus 3 equals 0, x plus 1 equals 0, gives us x equals 3, and x equals negative 1. Now, just like y-intercepts, x-intercepts are ordered pairs, so we need to write them as ordered pairs. So we have two x-intercepts. There are two places where this graph crosses the x-axis, at 3, 0, and negative 1, 0. Now we have one more definition in this section. The point x comma y lies on the circle of radius r and center h comma k if and only if x minus h squared plus y minus k squared equals r squared. So to graphically show you what this looks like, we have this nice circle here. The very center of the circle is h comma k. The distance from the center to the edge of the circle is the radius r, and any point on here is represented by the ordered pair x comma y. So any point that fits on this graph would give a true statement when you plugged into this equation here. Now h and k, that center of the circle, is constant. That does not change. The same with the radius. Your variables, the things that change, depending on where you are on the circle, your x and your y might vary. So if we wanted to find the equation of a circle that had a center 3, negative 2 and a solution point 4, negative 1, well, what we're looking at doing is finding this equation right here where we fill in h, k, and r with their constant values. Well, the nice thing is we were given the center, so we know h is 3 and k is negative 2. The other constant we need to fill in is r, the radius. The radius isn't given to us, but a solution point is. So we know in this equation, if we plug in 4 and negative 1 for x and y respectively, that we would get a true statement. So that's what we'll do. We'll plug in 4 for x, negative 1 for y, 3 for h, and negative 2 for k, and then we'd be able to solve for r. So 4 minus 3 is 1. 1 minus negative 2, remember subtracting a negative turns into a positive, so that's negative 1 plus 2 gives us 1, and we have 1 squared plus 1 squared equals r squared. Combine that together, and we get that r squared is 2. Now, we don't actually have to take the square root to find that the radius is the square root of 2. Since the equation is already set up r squared, and we know r squared is 2, all we have to do is just plug in 2 for r squared. So the formal equation of this circle is x minus 3 quantities squared plus y plus 2 quantities squared equals r squared, which remember is 2. That's it for now. See you next time.